We don't talk about it enough, but cooling might just be the defining technology of the climate era. From California to Delhi, the heat is rising fast, and our current air conditioners, they're not just outdated, they're dangerous to our health and the planet. What if the very machines keeping us cool are heating up the earth? This is Future Forward. Subscribe now, and let's explore why the world needs a cooling revolution. Sneha Satcher grew up in Delhi. She knows heat, but today, her hometown feels unbearably hotter. Now living in California and working with the Clean Cooling Collaborative, she sees the problem from both ends: rising global temperatures and the urgent need for safer, smarter cooling. In the global south, outdoor workers are struggling to survive the heat. Just 20 minutes of relief in a cooling shelter can save a life or a livelihood. And it's not just a comfort issue. It's an economic, health, and survival issue. But here's the twist. The air conditioners we rely on are leaking dangerous refrigerants, gases like HFCs that warm the planet thousands of times more than carbon dioxide. Refrigerants are at the heart of today's cooling systems, and they're leaking into homes, into the atmosphere, and into the climate crisis. The market for cooling is worth $235 billion and growing fast. But the current systems, vapor compression machines, depend on fluids like HFCs, propane, or ammonia, each with its own risks. Some are flammable, others toxic. Some need high-pressure machinery that's too expensive or unsafe for mass deployment. And yet, we can't ditch A/CS overnight. As Satcher puts it, we still need refrigerants for at least another decade. But what if we didn't need refrigerant fluids at all? A new generation of solid-state cooling technologies could completely transform how we chill our homes, offices, and even food. Magnotherm uses magnets to cool materials without liquid refrigerants. No toxic chemicals, no pressure tanks, just solid metals and magnetic fields. So far, they've built around 40 beverage coolers and 5 refrigerators, all in-house. CEO Timur Serman admits, the magnets are expensive, but they don't break. They're reusable, and they work. Thermoelectric cooling, Phononic, USA/Thailand. Phononic is making ultra-thin cooling chips that use electricity to move heat, just like computer processors. They're already in data centers, supermarkets, and medical fridges. No moving parts, no noise, and best of all, they only run when needed, cutting energy waste. CEO Tony Addy calls it coolness on demand. Elasticaloric cooling, SMACool, EU. Elasticaloric cooling uses mechanical stress on metals to produce cooling. Projects like SMACool in Europe are testing it now. While the cooling capacity isn't yet as high as traditional AAC, progress is rapid. One Hong Kong team recently broke the 1,000W cooling threshold using graphene nanofluids. These are more than just innovations. They're revolutions. According to RMI's Lindsay Rasmussen, these systems not only avoid polluting gases, they could soon outperform traditional AC units in both cost and efficiency. There's one catch: scale. Most solid-state systems are still expensive, in early stages, or only available in wealthy countries. But with climate demand surging across Asia, Africa, and Latin America, the big question now is, can we make these techs affordable for those who need them most? Because if we don't rethink cooling, rising heat will turn entire cities into unlivable zones, and the climate cost of traditional AC will only grow worse. Revolutionary cooling isn't a luxury, it's a climate necessity. What do you think? Should governments and companies invest more in radical cooling tech? Drop your thoughts in the comments. Like this video if you've ever wondered how we'll survive the heat ahead. Subscribe to Future Forward for weekly dives into world-changing technologies. Next up, could clean cooling become the new solar power? Don't miss it.